Hi guys, this is Miss Gold. Today's lesson is Module 3, Lesson 5, Solving Equations Algebraically. Your outcomes for today's lesson are students understand and use the addition, subtraction, multiplication, division, and substitution properties of equality to solve word problems leading to equations of the form px plus q equals r and the product of p and x plus q equals r, where p, q, and r are specific rational numbers. Students understand that any equation with rational coefficients can be written as an equation with expressions that involve only integer coefficients by multiplying both sides by the least common multiple of all rational number terms. Really what this lesson is going to do is solidify for us what we've already been looking at the end of Module 2, which was solving equations. So in this lesson, we are going to get our specific process for solving equations. The first thing we need to look at is the idea of inverse operations or opposite operations. For example, we know that addition is the opposite operation to subtraction. And multiplication is the opposite operation to division. One other operation that you're going to see in 8th grade and beyond would be squares and square roots. But we'll take a look at that more in 8th grade. So a linear equation is an equation that contains a single variable, usually x, raised only to the first power. So for 8th and 7th grade, we're going to focus on linear equations. And then in algebra, you're going to combine your knowledge of linear equations and then start to look at other types of equations such as quadratics, exponential equations, and step functions. So as we talked about at the end of Module 2, we want to set a process for solving equations. And the main ideas that we talked about in the end of Module 2 was to always first simplify each side of the equation using PEMDAS, and then solving for the variable using the opposite of PEMDAS and the opposite of each of those operations. So let's just review here. The P stands for parentheses, E stands for exponents, M and D, we are always going to group these two together. M stands for multiplication, and D stands for division. Same idea with addition and subtraction, you always do those left to right, so we are going to group those together as well. So A stands for addition, and S stands for subtraction. The one part of PEMDAS that is really new to us is O. So we're really going to call this PEMDAS O for solving. O meaning opposite. And what I'd like you to do is to always show an arrow coming off the O like this. And what it really shows you is we're going to go through PEMDAS this way, and then when we're ready to solve, we're going to go this way using the opposite operation. So you'll look for addition and subtraction first and use the opposite operation to get rid of them. Then you'll look for multiplication and division and then use the opposite operation to get rid of those. So let's start with a word problem. Julia, Keller, and Israel are volunteer firefighters. On Saturday, the volunteer fire department held its annual coin drop fundraiser at a streetlight. After 1 hour, Keller had collected $42.50 more than Julia, and Israel had collected $15 less than Keller. Altogether, the three firefighters collected $125.95. How much did each person collect? The first thing they'd like us to do is to find the solution using a tape diagram. And what you should notice here is that they talked about Julia, they talked about Keller's amount in terms of Julia. So that's what we really want to start with. Julia is our unknown because they then defined Israel in terms of Keller. So we're going to let our single block equal Julia's money. So it said Keller had collected $42.50. It told us that Keller had collected $42.52 more than Julia. So that would be added on to Julia's amount. So here's Julia, and then this would be $42.50. So this would equal Keller's amount. The last part defines Israel's amount, and it said that Israel collected $15 less than Keller. So if he collected $15 less than Keller, what I want to do is subtract 15 from $42.50. And so that is going to leave us with $27.50 to represent Israel's money. In the problem, they told us that altogether the firefighters collected $125.95. That really implies that we're going to put all of three of these together in a single bar. The total value of the bar being $125.95. Now we know that we're going to want to rearrange this bar and put together our like terms, so we're going to create an equivalent bar, so it still has a value of $125.95. So if I isolate this part of the bar, we can subtract 70 from $125.95, and that will give us $55.95. So if each of these have the same value, we can divide it by 3, and that will give us the value for one unknown box, which is $18.65. So that tells us how much Julia collected, but we can plug that in to our numbers here and here. So this is $42.50 added on to $18.65, and for Israel, $27.50 is going to be added on to the $18.65. And we could really check our work by adding all three of these together to make sure that they equal $125.95. Let's take our problem and actually break it down. The first thing we're going to do is we're going to let J equal the amount of money that Julia collected. So if I want to represent Keller's amount of money collected, that would be J plus the $42.50 because he collected $42.50 more. So this would be J plus $42.50. And notice this is an expression, not an equation, because there is no equal sign. Using the expression for Julia and Keller, then we want to represent Israel. So if we just use what they gave us in the problem, they told us that Israel collected $15 less than. Now, less than we interpret as subtraction, but it also means you're subtracting the number from what we're talking about, which is Keller's amount collected. And that is J plus $42.50. So when I subtract $15 from $42.50, we will get J plus $27.50. And you can see those are mirrored into the bar modeling method that we used. Using the expressions written above, write an equation in terms of J that can be used to find the amount each person collected. So here we are going to add all of our three amounts. So we have Julia plus Keller plus Israel. And it is equivalent to $125.95. Let's go through and solve this. So the first thing I see here is I have the distributive property. So I'm going to show that these are ones that are being multiplied in. And so when I rewrite this, when you multiply anything by 1, it doesn't change it. So this is really just getting rid of the parentheses for us. Essentially, the step that I was doing there is multiplying. So I don't want you to get confused with the fact that there were parentheses and interpret that as the multiplication. Really what this means is when you go through PEMDAS, you have parentheses, but you look inside the parentheses and see if there's anything you can do to simplify. I can't combine J and 4250 just like I can't combine J and 2750. So even though we see parentheses, it's not considered the P in our PEMDAS. What it is here is M, which is multiplication because we're multiplying a 1. So we just did multiplication, part of PEMDAS, to help us start to simplify before we solve. After we go through and do multiplication, we don't see any division. The next thing I look for is addition and subtraction, which in this case would be considered combining like terms. So here I have J, J, and J can be combined to give us 3J, and 4250 and 2750 can be combined to give us $70. So now I have fully simplified this problem, and now I'm ready for O, which is the opposite. And when I go back through, I'm going to start with addition and subtraction. So the first thing I see is we have addition here. So I'm going to get rid of it by doing the opposite operation, which is subtraction. And really what this goes back to is this is the additive inverse, which is going to give us 0. But I'm not going to get you to write 0. What I'd like you to do is just show this being crossed off because it has a value of 0, and drop down what's left, which is 3j. If it helps you to keep yourself organized, you could also draw the wall, and then your equal sign will always stay directly on the wall. So when I subtract these two, we are left with $55.95. Now here we have 3 times j. If it helps you to write the dot to identify the multiplication, then you can do that. And then we are going to do the opposite operation of multiplication, which is division. So I'm going to divide by 3. Now, what I want you to realize here is we're going to cross these off, but it's not that they cross off and become 0. What they're really crossing off to become is 1, because 3 divided by 3 is 1, and then 1 times j will give us j. So our final answer here is 1865, which matches what we found in our bar modeling. And then we're going to plug those in to both Keller's expression and Israel's expression. To get what they collected in the fundraiser. So you'll see that we ended up with the same amounts that we did using the bar modeling. In example 2, you are designing a rectangular pet pen for your new baby puppy. You have 30 feet of fence barrier. On a whim, you describe what you would like the length to be 6.5 feet longer than the width. Draw and label a diagram to represent the pet pen and write an expression to represent the width and length of the pet pen. So notice they asked us to draw and label a diagram. That's always a good idea to do in this type of visual scenario. So it will really help you to visualize what's going on here. So if I have a rectangle, I do not know the width in this. So let's actually define the width. We'll say let W equal the width. A let statement is very important. If they do not give a variable for you, you need to define one. So that tells us that our width here and here are W. So we had said on a whim, we would like the length to be 6 1/3 feet longer than the width. So we need to add on 6 1/3 foot to the width. So this would be W plus 6 1/3 for our lengths. So over here, we'll just define that. W plus 6 1/3 equals the length. Then they ask us to find the dimensions of the pet pen. Now we have 30 feet of fence barrier, and essentially what we're talking about here is the perimeter. So we would want to add up all of our sides. So let's add them up. W plus 6 1/3 plus W plus 6 1/3. And the total amount that we have is 30 feet, so this will be equivalent to 30. So let's go through PEMDAS here. First thing I look for is parentheses. I have them, but there's nothing to do inside either of these. I can't combine like terms. So technically, while we see them, we don't have anything to do to evaluate parentheses. We don't have any exponents. What we do have is multiplication, because what we're multiplying is an invisible 1 and using the distributive property to multiply. So this would be W plus 1 times W is W, and 1 times 6 1/3 is just 6 1/3. So the same thing would happen for the rest of this. Now that we've done multiplication, I don't see any division, so now I'm looking for addition or subtraction, which is combining like terms. So if I count them up, I have 1, 2, 3, 4 W's. And if I add together 6 1/3 plus 6 1/3, we get 12 2/3. So I'm going to start by drawing the wall. I've gone through PEMDAS, so now I'm going to do the PEMDAS O part, and we always start doing the opposite operations by starting at the end of PEMDAS and working our way backwards. So the first thing I'm looking for is addition or subtraction. I see addition here, so I'm going to do the opposite operation and subtract 12 2/3 from both sides. Remember, whatever we do to one side, we always have to do to the other. That's how we keep the balance of an equation. These are additive inverses of each other, so they add up to the additive identity of 0. And we're left with 4w is equal to 30 minus 12 2/3. What we can do here is actually borrow, making this 29 3/3. So we're left with 1/3 as the fraction. And 29 minus 12 leaves us with 17. Now I have multiplication because it's 4 times w. We get rid of multiplication by doing the opposite operation, which is division. And if I do it to one side, I always have to do it to the other side. 4 divided by 4 is 1, so these will cancel. 1 times w is w. And my final answer is 4 1/3. Now that just tells me the width, but it actually asked us to find the dimensions of the pet pen. So I have to make sure that I actually answer the question. So when we have the w, now we can find the length by plugging in 4 1/3, 4w in the length expression, giving us 10 2/3 for the length. So it's a word problem. Let's give a worded answer. The width is 4 1/3 foot, and the length is 10 2/3 foot. Example 3 says the total number of participants who went on the 6th grade field trip to the Natural Science Museum consisted of all the 6th grade students and 7 adult chaperones. 2/3 of the total participants rode a large bus and the rest rode a smaller bus. If 54 of them rode the large bus, how many students went on the field trip? So if we want to know how many students went on the field trip, that's what we want to let our variable be equivalent to. So we're going to say let x equal the number of students. If we have the number of students be x, then x plus 7 would be the total number of participants. And notice I put x plus 7 because there were 7 adult chaperones. So now we can create our equation by interpreting the statement 2/3 of the total participants rode the large bus. So 2/3 of is to multiply, and we have the total number of participants was represented by x plus 7, and it should be equal to the total number of participants that rode the large bus, which was 54. Now, typically I would always push PEMDAS for you to simplify and then solve an expression. And we can do that here, it's fine. However, I do want you to notice, if I go through and do distributive property, we're gonna have 2/3 x, and 7 is not divisible by 3, so we're also going to have a fraction there. If you want to avoid fractions altogether, another option would be to use the opposite operations to get rid of the fraction first. So here, we can get rid of multiplying by 2/3 by either dividing by 2/3, or what I like better, which is multiplying by the reciprocal. Notice here, the 3's are going to cancel and the 2's are going to cancel. But remember, in an equation, whatever you do to one side, you always have to do to the other side. So we're going to multiply over here by 3/2 as well. So over here, we can draw our wall. We'd be left with x plus 7. And here, I'd like to do the things in my head that I can. So 54 divided by 2, if I take half of 50, I have 25, and half of 4 is 2. So 25 plus 2 is 27, and then 27 times 3 is 81. This leaves us with a simple one-step problem. The only operation we have left is addition, so I'm going to do subtraction to both sides. 7 minus 7 are additive inverses of each other, so we're left with just x, and 81 minus 7 leaves us with 74. So that tells us that 74 students went on the field trip.